Something huge just happened in the robot world, and no one saw it coming. Out of nowhere, a Chinese tech giant made a move that could change the entire future of humanoid robots. Factories went into overdrive, corders exploded, and suddenly, even Elon Musk's Tesla project was under pressure. But what exactly did they build, and why is everyone so nervous about it? UBTECH, based in Shenzhen, reported a surge of industrial orders for its Walker S2 robot through 2025. The Walker S2 is designed with an autonomous battery-swapping system that enables continuous operation without human assistance. The robot's development represents a move from experimental prototypes to large-scale industrial deployment. The model was first shown publicly in July 2025, followed by a 250 million yuan contract for use in major industrial facilities. Another 159 million yuan deal was announced for a data collection center in Sichuan province, bringing the year's confirmed total above 800 million yuan. UBTECH scheduled delivery of the first mass-produced units for November 2025. The robots are being introduced to real manufacturing and logistics environments, indicating that China's robotics industry is entering an active commercial phase. XPENG, known primarily for electric vehicles, unveiled its humanoid robot named Iron. The robot operates using solid-state batteries and features a bionic muscle system combined with advanced artificial intelligence control. XPENG stated that Iron would be produced in both male and female configurations and aimed at office, retail and service environments. Mass production is expected to begin before the end of 2026. Meanwhile, Unitree Robotics advanced its own humanoid model, the G1. This robot is designed with force-position hybrid control technology, giving it precise manipulation abilities similar to a human hand. The G1 targets educational and industrial markets and is also slated for commercial-scale production. Together, Iron and G1 highlight how China's robotics companies are developing in parallel across both industrial and service sectors. In the United States, Tesla's humanoid robot Optimus remains under development. Tesla describes Optimus as a general-purpose bipedal robot capable of performing repetitive or hazardous tasks. Elon Musk has stated that up to 80% of Tesla's future valuation could eventually come from the Optimus program. Despite these ambitions, the company's progress has been slower compared with China's industrial rollouts. As of late 2025, Tesla has continued testing limited prototypes and is refining its machine learning strategy. The company has shifted from motion capture training to a vision-based training approach similar to the one used in its self-driving vehicles. Production challenges have also emerged due to restrictions on exports of rare earth magnets from China, materials essential for Optimus's electric motors. Tesla plans to produce thousands of Optimus units by the end of 2025, but no large-scale commercial deployment has yet been confirmed. The robots remain in controlled testing inside Tesla facilities. By contrast, UBTECH and other Chinese firms are already delivering robots for operational use in logistics, manufacturing, and data facilities. This difference shows how China's robotics sector is rapidly moving from research to revenue. China's push aligns with its broader industrial policy, promoting automation and artificial intelligence to upgrade factory productivity and reduce labor dependence. Government support has been strong, with robotics classified as a strategic priority. The Walker S2, XPENG Iron, and Unitree G1 collectively represent the country's strategy to gain leadership in humanoid robotics across multiple application fields. These developments could significantly reshape manufacturing dynamics, cost structures, and global labor allocation. Despite fast progress, several challenges remain across the industry. For all humanoid robots, operational stability, maintenance costs, and safety in human environments continue to require technical refinement. UBTECH's growth in sales has not yet produced profitability. The company recorded a first-half 2025 net loss of about 440 million yuan, even as revenue rose over 27.5% to 621 million yuan. High production and research costs remain barriers to mass affordability. Experts also emphasize that humanoid robots still struggle to perform complex physical tasks in unpredictable environments for long durations. In Tesla's case, the training requirements for Optimus are considered significantly higher than those for the company's vehicle software. Optimus's perception and coordination must handle multi-joint motion in three-dimensional spaces rather than a fixed vehicle platform. This makes the scaling of training data and computing power a substantial hurdle. Musk has indicated that the company's artificial intelligence team is expanding resources to accelerate learning models for Optimus, but production readiness remains uncertain. For China's companies, the next stage involves refining reliability and cost per unit while expanding integration with existing automation systems. UBTECH's Walker S2 has already been assigned to large industrial sites for assembly and inspection tasks. XPENG is planning controlled deployments of its iron humanoid robots in showrooms and corporate spaces to demonstrate performance in public environments. Unitree's G1 continues to attract interest for training and research use, contributing to broader robotics adoption within China's education and technology ecosystem. Across the global market, these advancements mark the transition of humanoid robotics from prototypes and demonstrations to real industrial roles. As of late 2025, China holds measurable advantages in volume orders and actual deployments. The United States, through Tesla's Optimus and other initiatives, remains a major player, but faces slower commercialization timelines. The competitive momentum underscores a changing landscape in automation. Chinese manufacturers are entering a production phase, delivering hundreds of working robots, while American counterparts remain in testing. Elon Musk's projection that Optimus could be central to Tesla's long-term value will depend on the company's ability to achieve similar industrial penetration. The rapid development and commercialization pace in China illustrate a significant lead in humanoid robot deployment. China's government continues to emphasize robotics integration as part of its manufacturing upgrade agenda. The presence of UBTECH's Walker S2 on factory floors, combined with the emergence of XPENG's Iron and Unitree's G1, signals that the next stage of humanoid automation has already begun. Meanwhile, Tesla's Optimus project, though technologically ambitious, remains in a critical phase where testing and scaling must transition into tangible production output to keep pace with the accelerating competition. Something big just happened in China's tech world. XPENG didn't just build another robot, they built a challenger. The new Iron model looks, moves and reacts so human that people asked if it was real. This might be the first true rival to Tesla's Optimus. Iron stands 178 centimeters tall and weighs 70 kilograms. The robot features 62 active joints that enable movements such as shrugging, twisting and balancing on uneven surfaces. Each hand contains 22 degrees of freedom, allowing it to manipulate both small tools and large boxes. The robot incorporates a humanoid spine design, bionic muscles, and full-coverage soft skin. A curved display wraps around its head to form an expressive face that changes while speaking. The robot runs on 3 XPENG Turing AI chips that deliver 2,250 trillion operations per second in computing power. XPENG integrated its Vision Language Action System, which connects what Iron sees with its subsequent actions. The robot utilizes a combination of 3 large AI models: VLT, Vision Language Task, described as the core engine for autonomous decision-making; VLA, Vision Language Action, adapted from XPENG's Autonomous Driving Division; and VLM, Vision Language Model, also originating from the company's automotive work. XPENG equipped Iron with an all-solid-state battery, marking what the company describes as the first use of this battery technology in a humanoid robot. The solid-state battery provides extended runtime, lighter weight, and enhanced safety compared to traditional battery designs. The robot can walk at approximately 2 meters per second while avoiding obstacles. XPENG's development team added passive degrees of freedom at the toes to create what observers described as a light and gentle stride. During the unveiling, CEO He Xiaopeng stated that during rehearsal, some colleagues asked, "Is there a real human inside the Iron?" The robot demonstrated a catwalk performance with what attendees described as natural, fluid movements and realistic human posture. XPENG has been developing robots for 7 years, beginning with quadruped designs before transitioning to humanoid forms. According to Brian Gu, XPENG's vice chairman, the company initiated its humanoid robot efforts ahead of Tesla. The first generation Iron was unveiled at the November 2024 AI Day event. The company targets mass production of Iron by the end of 2026. He Xiaopeng outlined the initial deployment strategy during the event, stating the robots will first serve in commercial settings as tour guides, sales assistants, and office building guides, beginning at XPENG facilities. He downplayed near-term household applications, explaining that factory use remains too costly given labor prices in China. He stated he believes humanoid robots will become widely used in manufacturing operations and homes, but placed that timeline at 3 to 5 years for industrial applications and 5 to 10 years for safe and useful home deployment at scale. Chinese steel producer Baoshan Iron and Steel became an ecosystem partner for Iron, with plans to deploy the robot for equipment inspection in industrial settings. XPENG released an SDK software development kit for global developers to build applications for the humanoid robot. Tesla's Optimus robot, announced at the company's AI Day in August 2021, stands 173 centimeters tall and weighs 57 kilograms. The robot is designed to measure 5 feet 8 inches tall with a planned carrying capacity of 20 kilograms. Tesla showed its first working prototype in 2022 and has demonstrated various iterations since then. CEO Elon Musk projected a price range of $20,000 to $30,000 for production units. During Tesla's Q3 2025 earnings call, Musk announced plans to unveil Optimus V3 in early 2026, stating it won't even seem like a robot, but rather like a person in a robot suit. Tesla aims to produce approximately 5,000 Optimus robots in 2025 for internal factory use, with production scaling to 50,000 units in 2026. The company announced plans to build a production line capable of manufacturing 1 million Optimus robots annually, though Musk cautioned the timeline would be extended due to the robot's complexity, noting it contains 10,000 components and the absence of an established humanoid robot supply chain. XPENG's AI Day announcement included 3 robo-taxi models set to launch in 2026, using 4 Turing AI chips that deliver 3,000 TOPS of computing power. The company partnered with Alibaba's AutoNavi and AMAP for robotaxi deployment. Co-president Brian Gu told CNBC that robotaxi technology is happening faster than we anticipated, noting the company's shift in outlook from April 2024, when he stated self-driving taxis wouldn't become significant for at least 5 years. He Xiaopeng stated during a press conference following the AI Day presentation that he doesn't know how many robots XPENG will sell in the next 10 years, but predicted it will exceed the number of cars sold. The company positions Iron as part of a broader strategy spanning electric vehicles, flying cars, robotaxis, and humanoid robots under a unified AI platform.
The Optimus opportunity is just right around the corner. It's very likely that human robots are going to be robots that we can deploy into the world relatively easily. And this is the first robot that really has a chance to achieve the high volume and technology scale necessary to advance technology. And so I think that
NVIDIA just powered a robot that is already working in 25 hospitals across America, while Elon Musk's Optimus is still stuck in testing labs. Moxy 2.0 has finished over 1,250,000 real deliveries, while Tesla's bot is practicing folding laundry. The race is over before most people knew it started.
The thing about human robotics is not just the fact that if it worked, it could be quite versatile. It is likely the only robot that is likely to work. And the reason for that is because technology needs scale. Most of the robotic systems we've had so far are too low volume. And those low volume systems will never achieve the technology scale to get the flywheel going far enough, fast enough, so that we're willing to dedicate enough technology into it to make it better. But humanoid robot, it is likely to be the next multi-trillion-dollar industry.
The announcement came on October 28, 2025. Diligent Robotics revealed Moxy 2.0 at NVIDIA GTC Washington. The new robot runs on NVIDIA IGX Thor. Andrea Tomaz is the CEO and co-founder of Diligent Robotics, and she made it clear what makes this different. Interactive environments are the hardest to simulate, but they're where robots can deliver the most value, Tomaz said. We've collected millions of examples of Moxy operating in dynamic human environments, now built into Moxy 2.0, the first system to truly reflect that lived experience and everything we have learned. Moxy 2.0 has something Tesla Optimus does not have: real-world data from 3 years of hospital work. Over 1,250,000 deliveries happened in busy medical centers. Nurses and pharmacy staff use these robots every day. The dataset is one of the largest collections of human-robot interaction ever recorded. This is not simulation training. This is actual work in crowded hallways with people, beds, and wheelchairs. The robot uses NVIDIA's newly revealed IGX Thor platform. This platform runs on NVIDIA Blackwell chips. The system was built for industrial and medical applications. Tamaz explained the power difference. Moxy 2.0 has 10 times the compute of Moxy 1.0 thanks to the rapid advancement of the NVIDIA Jetson line, she said. We're excited about how the new NVIDIA IGX Thor platform pushes the boundaries of AI performance at the edge, unlocking possibilities for future generations of intelligent, human-centered robots. The new Moxy 2.0 robot from Diligent Robotics shows what happens when computing power meets real-world reliability. Built on NVIDIA's AI chips, Moxy 2.0 processes information faster than ever, spotting obstacles, predicting movement, and reacting instantly. The redesign focuses on durability, scalability, and user feedback, easier service panels, stronger handles, and hardware built for thousands of hospital shifts. Unlike most demo robots, Moxy 2.0 already works in over 25 US hospitals, performing real tasks, delivering meds, transporting lab samples, and moving supplies between departments. Diligent plans to double its hospital base every year and reach thousands of deployments by 2030. Each robot learns from real experience, creating a powerful feedback loop. More data makes the AI smarter, smarter robots get deployed more widely, and deployment brings in more real-world data. NVIDIA isn't just selling chips, it's selling the brains for modern robotics. Its Isaac platform and GR0T foundation models provide simulation and training tools every robot company needs. From Boston Dynamics to Agility Robotics, Hyundai, and Foxconn, industry giants use NVIDIA's stack for vision, movement, and simulation. That means NVIDIA profits no matter who wins the robot race. Every serious robotics program needs the company's AI infrastructure, making it the quiet champion of the new physical AI era. Meanwhile, Elon Musk's Optimus keeps missing milestones. Musk unveiled it in 2021 and promised production in 2022, then 2023, then 2025. Each date slipped. Even as of 2025, Tesla has shown only short demos and tightly controlled factory appearances. Critics note that many public demos involved remote-controlled robots rather than fully autonomous systems. Musk continues to promise tens of thousands of units by 2026, but production details, pricing, and performance remain unclear. Key staff changes, like program head Milan Kovac's resignation in 2025, have fueled skepticism. Optimus videos go viral, but there's still no verified proof of sustained, independent operation. In contrast, Moxy has completed over 1,250,000 real deliveries in hospitals. Tesla's humanoids, by comparison, remain limited to internal trials. Moxy ships to paying customers in 2026. Optimus might, if deadlines hold. Global robotics is projected to hit $130 billion by 2035, with $38 billion from humanoids and $94 billion from industrial systems. But building robots at scale is hard. Balance, dexterity, battery life, and safety take years of iteration. That's why Diligent's approach works: start narrow, perfect one use case, and expand. Hospitals face chronic labor shortages. Moxy fills that gap, proving immediate value and building customer trust. Every shift it completes adds training data for future versions. Tesla's do-everything robot dream sounds bigger, but risks collapsing under its own ambition. Each new feature adds complexity, and every missed promise erodes confidence. Musk has a record of over-optimistic timelines, from self-driving cars to the delayed Roadster and Cybertruck. Diligent Robotics delivers a product, not a prototype. Hospitals buy Moxy because it saves staff time, cuts delivery delays, and runs reliably. The company built a sustainable business before expanding to senior living facilities through the AARP Age Tech Collaborative. Tesla has yet to sell a single robot externally or report any Optimus revenue. Its trillion-dollar projections remain speculative. By contrast, Diligent already earns real money solving real problems. And behind every successful robot, including Moxy 2.0, stands NVIDIA. Its chips and AI stacks enable the vision, motion, and simulation that make physical AI possible. Whether the winning form is humanoid like Optimus, agile like Atlas, or utilitarian like Moxy, doesn't matter. NVIDIA supplies the intelligence powering them all.